Quant explained, breaking down quant finance concepts, current limitations, and future perspectives in quantum computing. What are the current limitations of quantum computing in practical finance applications?
I would say that while the potential of quantum computing in finance is very, very vast, the technology currently faces several significant limitations that impede its practical deployment in the industry. So firstly, quantum decoherence and error rates are major technical hurdles. Quantum computers are highly susceptible to environmental noise and other quantum interference, which can cause qubits to lose their quantum coherence very quickly. So this sensitivity demands incredibly precise operating conditions, typically near absolute zero temperatures. So usually what we see on the pictures of the quantum computers is a huge fridge. And what is needed is sophisticated error correction techniques that are still under development. So these factors limit the duration and complexity of computation that current quantum computer system can handle, which is partially challenging for financial models that require extensive and sustained computation. The limited number of qubits in today's quantum computers also constrains the usability. So most current systems operate with a few dozen qubits, which is insufficient to surpass the capabilities of classical computers, especially for commercial applications. So financial calculations often involve analyzing large metrics and complex derivatives pricing model, for instance, that require a vast amount of computational resources. And moreover, the programming and development of quantum algorithm that can effectively handle such financial tasks are still in the nascent stages, and existing algorithms need to be adapted, or I would say we have to invent new algorithms, quantum version of the algorithms, to harness quantum computing's potential in the finance. And integrating quantum computing with the existing technological infrastructures in finance is another considerable challenge. As we know, financial institutions heavily invested in classical computing infrastructure, and the shift to incorporate quantum computing involves not only financial investment, but I would say that it also a steep learning curve for IT personnel and developers. So quantum computers work in a different way than classical computers. So the learning curve, how to build that software, is very, very high.
How do you envision quantum computing evolving in the next decade, and what are its implications for the financial industry?
Usually it's hard to predict the future, but I would say that over the next 10 years, quantum computing is likely to evolve dramatically, pushing past some of its current experimental and theoretical limitation towards more stable and scalable application. And we anticipate significant advancements in quantum error correction. You might hear about the latest achievements of Quantinuum and Microsoft or IBM in terms of quantum error correction, which is one of the main challenges. And it increases the coherence time of qubits and making quantum computation much more reliable and accurate, I would say. So these advancements will enable quantum computers to tackle larger and more complex problems, reaching beyond the capabilities of classical computers in some areas. So for the financial industry, this evolution will bring several profound implications. Firstly, quantum computing could greatly enhance computational finance areas such as risk management or asset pricing or even optimization. For example, quantum algorithms could improve the efficiency and speed of Monte Carlo simulation, a method widely used in financial modeling for instance, for valuation of option. And these simulations rely heavily on random sampling methods, where quantum computing can provide exceptional speed up. Another promise area is in cryptography, and which is very, very important for financial sector. Quantum computers pose a risk to current cryptography, current encryption methods, because they could potentially break widely used cryptography algorithms, undermining financial security systems. However, this also opens avenues for quantum cryptography, which could provide new means to secure data transmission, a critical aspect for financial transaction. And lastly, the implication for data analysis and machine learning in finance are significant, I would say. And quantum enhanced algorithms and quantum inspired algorithms used today could potentially sift through vast data sets much more effectively, helping financial institutions make more informed decisions by identifying patterns and correlations which we are not able to identify using classical algorithms and classical computing power. And as we move towards more practical and robust quantum computing application, financial industry and financial institutions that start adapting to and investing in quantum technology may gain a distinct competitive advantage. And this shift would also drive, I would say, innovation in the financial products, the strategies, but I would say that it really can reshape the landscape of financial industry which we know today.
For more on quant finance, join the CQF Institute now.